All right, so this story problem says Jerry is trying to create an open top box by cutting squares off each corner of a 24 by 30 centimeter piece of cardboard. Jerry needs his box to have a volume of at least 200 cubic centimeters. What is the range of side lengths for the squares he will be cutting out? So I would start by drawing a picture. So here is my 24 by 30 rectangle, and we're going to be cutting, it says we're going to be cutting squares out of the corners to make like an open top box. So I don't know how big those squares are going to be, so I'm going to label their side lengths as X. That's what we're going to try to determine is the range of side lengths. Now, if each of these is X, this part here is no longer 30 centimeters because we've chopped an X off of each side. So that's 30 minus 2X. And similarly, this side is no longer 24 centimeters because we chopped an X off of each end, so it's 24 minus 2X. And then we're told that the volume has to be at least 200 cubic centimeters. And we know the volume for a box is just length times width times height. So I know then that 200 has to be less than or equal to the length, which is 24 minus 2X, times the width, which is 30 minus 2X, and times the height, which is X. So it's this times that, because remember those are the, when we're folding it up, that's going to be the height of the container. Okay, so at this point, what I'm going to do is could FOIL this all out and then subtract the 200 over, and I'd be left with like a degree 3 polynomial. I can tell it's a degree 3 because I have just the product of 3 degree 1 polynomials, and maybe I can factor that, but probably not. So I'm just going to go straight to the calculator to find the zeros for this function. So I'm going to go ahead and get rid of these guys and just type in 24 minus 2x times 30 minus 2x times x minus 200. So I'm just going to go, oops, and move that over. And I guess before I do this, let's just do a little bit of common sense what we can say about x. X is a length, so I know it has to be greater than 0. You'd have no box. And the biggest that length could be would be 12, because if x was 12 or more, you'd have no side over here. Again, you wouldn't have a box. So I know that it has to be between 0 and 12. So that's what I'm going to be concentrating at. And that's going to help me choose my initial window. So the x range I care about is really just going to be from 0 to 12, because I know any x-intercepts are going to need to fall between there. And I just kind of guessed at this y min and y max. I'm just taking a stab in the dark. And apparently it wasn't a good enough stab because I don't go up high enough. But it doesn't really matter because the parts I care about are right here. So I just need to find those two x-intercepts because any other x-intercepts I don't have to care about. So to do that, I'm going to choose the 0 command. And I'm going to move for the left bound. I'm going to move my cursor somewhere left of the first x-intercept, which is just right here. And then the right bound, I'll just move it somewhere to the right of it. And then anywhere for a guess is fine. So the first x-intercept is 0.29. Oops. So we'll just say these. And then I'll go find this other one over here. So again, second, trace, pick the 0 command, and I'll just move over until I'm close. It's just gonna take a minute. Oh, there I come. So that looks good as a left bound. Move on the other side of the 0. That looks good for a right bound, and then a guess wherever. So 1088 is my other one. And right away, I can tell by looking at my graph what my interval is, because I care about when this thing is greater than 0, which is whenever the graph is above the x-axis, which is exactly what I see here. So I can tell then my range is going to be from 0.29 to 10.88. And this is the correct answer. The answer on the, or the, what's it called? The answer key is incorrect. I don't know where that number came from, but that is not the correct solution. This one is. And that ought to do it.